What's going on, friends? Welcome to Dennis Simplifies. In this video, we are going to compute population standard deviation in C++. As usual, the algorithm first and then the code in C++. So, let's simplify. Write down a computer solution for finding the standard deviation of a given set of x values. The standard deviation is given by the following relation, where xi is a data point and x bar is the mean of the x. To the algorithm, since the user is going to enter values for x, we would like to take the x values from the user and store them as well, so that anytime we need the values, we will be able to access them. So first, we will ask the user to input the size of these x values. Now, we will allocate this size to the dereferenced array. You can see the asterisk, meaning the computer should create size memory spaces in the array where it is going to store the x values. I'm going to create an empty variable called sum, where the sum of the x values will be stored. And again, I'm going to create an empty variable called sumdev, where the values of the summation of the x values minus the mean all squared will be stored. From here, we are going to set a for loop which will run from 1 to size, and anytime it runs, the user should fill one space in the array with an x value and simultaneously add and store that value to sum until the loop ends, meaning we will be adding the x values as well as the user enters them. So as the user enters the x values, we'll be adding it as well. Now I end the for loop. With the sum and size of the sets, I can compute for the mean. Now, we are supposed to subtract the mean from all the x values from the equation, square it, and add them all up. Now you can see the reason why we store the x values in the array, so that we'll be able to access them at our own convenience. So we are going to set another for loop, which will run from 1 to size. And each time it runs, it should subtract mean from the x value at that point in the loop, square it, and add it to sumdev, where it will be stored. The POW means power, so everything in here to the power 2, as the equation says. Now we can end our for loop. With the sumdev and size, we can compute for the variance, and with the variance, we can compute for the standard deviation. The SQRT here means square root, so you should find the square root of the variance. Now we can print our results. If you want a thorough overview of how the for loop works, watch my previous video on mean and median, where I have explained in depth and also with visualizations how this for loop actually works. The link is in the description below. Before we take a look at our code in C++, I will encourage you to give this video a like and subscribe. Very well, to our code. I included the CMAT library because we'll be making use of the power and square root functions. Now in the int main function, I declared the mean, standard dev, variance, sum, and sumdev as a double. I also declared I and size to be integers and initialized sum and sumdev to be 0. Then I take the integer value of size from the user. Now I set the for loop that will take all the x values, sum them as well. I end the for loop with curly braces, and outside it, I compute for the mean. So you notice that in the for loop, as we take the x values, we store them in the array, and then we add them and store them as well. Now after computing for the mean, I set another for loop that will compute the total deviation. And outside the for loop, I compute for the variance and the standard deviation. This for loop will compute for the total deviation, and outside the for loop, I compute for the variance and the standard deviation. The POW and square root functions here are only made available by the CMAT library we included, remember. Now we print our results. This end line here is for readability sake. You should move to the next line or leave a space between the top and the bottom. You will notice this as we run the code. I'm going to enter some x values so we see how the code runs. I entered a size of 8. Then I also entered the x value for each memory space in the array, from I to size, which is 8 in this case. And on pressing enter via my keyboard, it displays our results, which is correct. So you can see the space I was talking about, the space between the top and the bottom. So if you, as I said, if you compute this on your calculator, you will know that our result is correct. So our code is running properly. Friends, that's it for this video. See you in the next video. Till then, apart, yeah.